Alright, welcome back again, viewers. In this tutorial, we're going to talk about the binary systems. So our focus will be on binary operations. So binary operations. Okay, so when you say binary operation, basically is it takes elements, two elements from the domain onto one element in the codomain. Yes. So for illustration, f of a, b, where a and b are from what? The domain, combining to give us what? The d, which is in what? The co-domain. Suppose we have the binary system operation AB, which is being defined as A plus B minus AB. Now it means that if I also say 2 with this operation 3, it means that this is the same as 2 plus 3 minus what? 2 times 3. And this is going to give us what? Um, 5 minus what? 6. And the answer is what? Negative 1. So that is it. And what? Binary operations. And these binary operations obeys or satisfy certain conditions. And we are going to talk about those conditions or those properties. Right. So the first one we are going to talk about under this system is the closure property. The closure property. Right. Then the second one is the associativity property. The associative property. Then we have the identity. The identity property. We have the inverse element or the property. So inverse element or what? Property. Then we have the commutative property. Right. So these are things that a binary system will satisfy, or those are what properties that a binary system will satisfy. Right. Now, let's take them one after the other. The first one, which happens to be the closure property. The closure property. Now, supposing we have G as an empty set. An empty set. Suppose we have G as an empty set. For all AB, a member of G, such that when we perform operations on them, that A star B should be a member of what? G. Then we can say that is what? Closed. Let's take an example on that and see. If I have the set, A with element 1, 2, 3, 4. Now, this set here is said to be closed if I pick any two elements from this set, then using any operation. So if I take 2 star 1, it should be equal to, or it should be a member of what? A. Right. So it means that if I'm considering addition, 2 plus 1, that will be 3. And 3 is a member of A. we can say that it is what? Closed. Right. So any operation that we perform on this, it should give us an element and what? Which is also a member of what? The set that we have. Then we can say that it is what? Closed. Now let's talk about the next property. The next property, the associative. So associative property. Supposing we have this our G as in an empty set as we defined earlier, an empty set. For all A, B, C, a member of G, such that A star B star C is the same as A, all right, is the same as A star B star what C. So in this case, when I'm to perform any operation on these three elements, which are also members of the set G, right? So in this case, when I have this, I can decide to perform the operation on these two here. Then I perform it, the answer with the first one here. Then it should be the same as this. Then we can talk about the associativity what? Property. Now the next one is the identity. We talk about the identity what? Element. So identity element. Right. So identity element. Okay. For all a member of G, which is going to be an empty set as we defined earlier, an empty set, sorry, which is this, there exists another element, which is a member of G, such that when I perform the operation on this, it should be equal to what? The A. So it means that if I perform under addition, so if I'm performing under addition, the operation is addition. If I have 2 plus a certain number, it should give me 2 back, right? And that happens to be what? 0. So under addition, the identity element is what? 0. So it means that if I add 0 to any number here, it should give me what? 2 back. If it is under multiplication, if I multiply 2 by a certain number, it should give me what? 2 back. And that happens to be what? 1. So under multiplication, the identity element is what? 1. Right. Now the next one, let's talk about the inverse property. The inverse property. Inverse element or the inverse property. For all a member of G, where G is being defined as what? And an empty set. There exists an element, this, which is also a member of what? G, such that A star A inverse is equal to A inverse star A should be equal to what? The identity element. So let's see. If this is performed under addition, so under addition, if I have 2 adding to a certain number, it should give me the identity element for addition, which happens to what? 0. So if I clearly, this is going to give out what? -2. So if I add 2 to negative 2 is going to give me 0, which happens to be the identity element for the addition. If it is under multiplication, 2 times a certain number should give me the identity element under what? The multiplication, which happens to be 1. And clearly this is going to give us what? Half. So if I multiply 1, 2 times what? The half, this is going to give me 1. And this is going to be what? The identity element. And this is the inverse element here. Right. So the inverse of 2 will be what? 1 on what? 2. Now the commutativity. Commutative. For all AB, a member of G, where G is being defined as what? And an empty set. A star B should be equal to B star A. And when that happens, we say that is what? Commutative. So if it is under addition, A plus B is the same as B plus what? A. If it is multiplication, A times B is the same as what? B times what? A. Right. So that is that for these properties. So binary systems or binary operations obeys all these conditions. Now, let's talk about something here. When a binary system, when a binary system obeys or satisfies only the closure property, is called the group point. Only closure property. Only closure is called what? Group point. When a binary system obeys or satisfies closure and associativity property, it is called a semi-group. Semi-group. So both closure and what? Associativity is called what? A semi-group. Now, when a binary system satisfies closure property, the associativity, and the identity, it is called what? Monoid. So it satisfies the closure, the associative, together with the identity. It is called what? Monoid. Right. Also, when a binary system obeys or satisfies the closure, the associative, identity, and the inverse, it is called a group. It is called a group. Now, if a binary system obeys the conditions for a group together with a commutativity, it is called what? Abelian what? Group. The abelian group. So it obeys the group properties together with what? The commutativity property. It is called the abelian group. The abelian what? Group. Then when a binary system satisfies closure, identity, and inverse, it is called a loop. It is called what? A loop. Then when a binary system obeys or satisfies closure and identity, it is called a quasi group. A quasi group. Yes. So that is that. So in our next tutorial, we're going to base on one of a binary system which satisfies the associativity, the closure, the inverse, and the identity, which happens to be what? The group. So in our next tutorial will be on what? Group. Thank you for watching.